So when we're talking about percentage yield just refers to a comparison of what you expect and what you get, now expressed as a percentage. For example, you can buy, let's say you buy uh, books at 20 kwacha and you buy the four of them, and you're expecting to sell these books which you bought at 20 kwacha at, let's say, 25 kwacha each. So if you multiply 25 times 4, you expect that you're going to make a 100 kwacha. Okay, so because you bought the four of them, of course you bought them at 80 kwacha, the four of them. Now we're not interested in what we bought, interested in what you want to make. You are expected to make 100 kwacha. This is your expectation. Now as you get to sell, you might not sell at 100 kwacha. For example, someone can come and say, okay, I want to buy two books, and instead of a 50 kwacha, I've got a 45 kwacha. So because of this, you see, instead of you getting a 50 kwacha of two books, you're going to get a 45 kwacha. That is going to reduce the amount that you're supposed to expect. And so to calculate your percentage yield, how much you've yielded or how much the profit is, percentage yield is given by the actual yield. For example, instead of you selling everything at 100 kwacha you planned, you're going to sell everything at 90 kwacha. So percentage yield is given by actual yield over theoretical. And then now we multiply by 100%. So in this case, the actual is 90, the theoretical is 100, and then times 100%. So the two zeros will cancel the two zeros. If you sell at 90, that means you've made a 90% yield. So you have just lost a 10%. The 90% is a gain to you. So this is how percentage yield calculations go. Percentage yield is given by actual yield over theoretical yield multiplied by 100%. So I'm going to use two practice questions to work this out. And the first one here, methanol, which is also called methyl alcohol, is the simplest alcohol. It is used as a fuel in race cars and is potential replacement for gasoline. Methanol can be manufactured by combining gases carbon monoxide and hydrogen. Suppose it is 68.5 grams carbon monoxide is reacted with 8.60 grams hydrogen. Calculate the theoretical yield of methanol. So again, if 3.57 grams of methanol, this is the symbol, is actually produced, what is the percentage yield of methanol? When you are in chemistry, you want to work out anything, the first thing that you should be able to determine is a balanced chemical equation. And in this case, if we read the statement, methanol, also called methyl alcohol, is the simplest alcohol. It is a fuel which is used in race cars and also a potential replacement for gasoline. So methanol can be manufactured by combining gaseous carbon monoxide and hydrogen. So what we have is carbon monoxide and hydrogen, and we need to know that hydrogen always exists as a diatomic gas. Okay, so this is what is going to give us methanol. Now we've been told, suppose 68.5 grams of carbon monoxide is reacted. So let me just put what reacted. The carbon monoxide, we have got 68.5 grams, and this is reacted with what? Is reacted with 8.60 grams of hydrogen. Question is, calculate the theoretical yield of methanol. So first, when the chemical reaction happens, we are forming methanol, and the symbol is here, CH3OH. Okay, like that. Is the chemical reaction balanced? So we can see we have got only one carbon, even here only one carbon. We've got one oxygen, even here one oxygen. But we have four oxygens here, I mean four hydrogens. But we only have two hydrogens, so we need to put a 2 in front of the hydrogens and this now is balanced. Okay, so I want to calculate the theoretical yield of methanol. In other words, how much methanol are we going to get? And in this case, we want to find the mass of methanol that we're going to get. Now, if you check, in this question, we've been given both masses for both reactants. And in such a case, you need to determine which one is going to be the limiting reagent. It's the limiting reagent that is going to determine the product. So how do you determine the limiting reagent? You have got two methods. You can assume that one of these masses is not given. You'll find the same one you are going to assume that is not given, and then you compare it with the actual one that you've been given. Or what we are going to do is we are going to use this one to determine how much of methanol we are going to produce, and then we are going to use this one to determine also how much of methanol we are going to produce. So the first thing we should be able to find is the molar mass for carbon monoxide, the molar mass for hydrogen. So carbon monoxide, oxygen, the molar mass is 16, carbon, the molar mass is 12. This is going to give us 28. If we talk of hydrogen, we have got 2 multiplied by hydrogen. The molar mass, of course, is a 1. Rounded off, if we check on the periodic table, can use 1.008. So 2 times 1, this will just give us a 2. And then the methanol, we have got hydrogen, molar mass 1, but we have got the 4 of them, so I'll just say 1 times 4, which is just a 4. And then you have got oxygen, molar mass 16. We have got carbon, molar mass 12. So 12 plus 16 plus 4, I can first start by saying 4 plus 16, which is a 20, and 20 plus 12, that is a 32. Okay. We have got all the molar masses. Now the next thing that we are going to do, let's first use carbon monoxide to be able to find the mass of methanol that is formed. And how do we do that? We are going to compare the mole ratios. So the number of moles of carbon monoxide should be equal to the number of moles of methanol. This is if you see there is a 1 in front of methanol, there is also a 1 in front of methanol, so their number of moles should be equal. And how do you find the number of moles? Number of moles is given by mass divided by molar mass. And this should be equal to also mass divided by molar mass. Remember, this side we're talking about methanol. So we're going to get the mass of carbon monoxide that has been given, that is 68.5, divided by the molar mass of carbon monoxide, that is 28. This should be equal to the mass of methanol that is going to be produced, divided by the molar mass, that is a 32. So at this point we want to remain with mass. So mass is going to be equal to, we are going to multiply these two terms. And then we are going to divide the answer that we get by this one. Remember, the 28 is going to multiply by m, but we want to remain with m, so we'll divide both sides by 28. Okay, we can do the multiplication there. We see what we're going to get. So this is going to give us about 87.68 grams of methanol. So this is, when we use carbon monoxide, this is the mass of methanol that we are getting. Now what of when we use hydrogen? So again, we're going to say number of moles of hydrogen is going to be equal to number of moles of methanol. But look, hydrogen has got a 2 in front, so we're going to say number of moles of hydrogen divided by 2. It's going to be number of moles of methanol. There is a 1 in front here, so divided by 1. And we know number of moles is given by mass over molar mass. But there is still a 2 there, so it's going to be 2 molar mass. And that is going to be equal to mass of methanol divided by the molar mass. So the mass of hydrogen that you've been given is 8.6, and then divided by 2, multiplied by the molar mass of hydrogen. We found it there, that is a 2. This is going to be equal to mass divided by the molar mass of methanol, that is a 32. So therefore we'll say mass is going to be, we're going to multiply this to 8.6 multiplied by 32, and then we're going to divide by this one, which is going to multiply with the m, so that is a 4. Let's see what we get. This is going to give us 68.8 grams of methanol. So you see, if you use carbon monoxide, you are getting 87.6 grams of methanol, and when you use hydrogen, you are getting 68.8 grams of methanol. This means that hydrogen is a limiting reagent. So the answer is this one. Okay. If there was a question which was saying determine the limiting reagent, you are going to compare these two masses. The one which gives you a lower mass produced is always the limiting reagent. So therefore, hydrogen is limiting. Now this question is saying calculate the theoretical yield of methanol. Therefore, the theoretical yield of methanol, that is the mass of methanol CH3OH, is going to be the smaller mass, which is 68.8. Okay. 68.8 grams. And then the next question is saying if 35.7, this is not supposed to be 3.5 but 35.7 instead of 3.57. Okay, so the goodness of using the method that I've used is when there is a question that is asking for you to determine the mass, it will be determined direct. But if you use the other method, if you find the limiting reagent, you again now come on to find the mass, so it is a bit long. So this one, if 35.7 grams of methanol is actually produced, what is the percentage yield? And percentage yield is given by actual yield divided by theoretical yield then multiplied by 100%. So the actual yield they've even told us is actually produced, that is 35.7. And then the theoretical is the one that you calculate in the question yourself. So this is the 68.8. Then you multiply this one by 100. So this is going to give us 51.5988%, and this one to a whole number we can write it as 52%. Okay, is that good?
Yes.
Okay, understand it here. It's the same question. So nitrogen gas can be prepared by passing gaseous ammonia over solid copper oxide at high temperature. The other products of the reaction are solid copper and water vapor. If a sample containing 18.1 grams of ammonia is reacted with 90.4 grams of copper oxide. So let's first determine the reaction. So we are saying a sample containing ammonia is reacted with copper oxide, and the condition has told us nitrogen gas can be prepared by passing gaseous ammonia over solid copper oxide. So when you react to ammonia with copper oxide, you're going to produce nitrogen gas. So this is the first product. The statement continues to say the other products of the reaction are solid copper and water vapor, which is just water, H2O, but in gaseous form. So this is the reaction. Now, is it balanced? We can see we only have one nitrogen here, but we have two nitrogens there. So we're supposed to put a 2 in front here. If we do that, we can see that we are going to have 6 hydrogens, but we only have 2 hydrogens there. So we're supposed to put a 3 here to make the hydrogens also 6. If we put these 3, we can see that we've made water. We've made the oxygens to be the 3 of them. So I need to bring a 3 at this point. If I put a 3 at this point, we can see that the coppers are also the 3 of them. So I also need to bring a 3 at this point. So now this is a balanced chemical reaction where all the atoms are now balanced. And from what we've been told 18.1 grams of ammonia reacts with 90.4 grams of copper oxide. Okay, that's the reaction. Now the question is, we want to find out which of these two is the limiting reagent. And then the other question is, how many grams of nitrogen will be produced. So to be able to do this, first let's determine the molar mass for ammonia. So we have got the 3 hydrogens, and then nitrogen, if we check the molar mass on the periodic table, that is a 14. So 14 plus 3, that is going to give us a 17. And then we have got copper oxide. Oxygen, the molar mass is 16, and then copper, from our periodic tables, it's okay, let me just try to check again. Okay, just a minute as I get to check out the molar masses. In case you've got a periodic table here, you can as well check out what the molar mass for copper is. So the molar mass for copper is 64. Do you have it? Can you confirm if you have a periodic table? Okay, so the molar mass of copper is 64. So if we add 64 and 16, it's going to give us 0, this is going to give us 8. So that's 80. Because there is a 1 that remained from the 6 plus 4. So again, nitrogen, the molar mass is 14, but there are the 2 of them. So 2 multiplied by 14, this is going to give us 28. We're going to use also the same method that we used for the previous one. Since the next question is asking us to find the mass of nitrogen that is produced, so we're going to consider nitrogen. So say number of moles of ammonia divided by 2 is going to be equal to number of moles of nitrogen divided by 1. Why? Because ammonia has got a 2 there, but nitrogen just has a 1 in front, though we cannot be able to see it. Mm.
When you put a 2 here, doesn't apply this side.
No,
Yes, it's down.
no, it doesn't apply this. So ammonia, the mass that you begin given, that's 18.1. Remember, number of moles is given by mass over molar mass, so that will be over molar mass. The molar mass for ammonia, that is 17. But also don't forget that we have got a 2 here, so we are going to have a 2 that is going to multiply, and this is going to be equal to also number of moles of hydrogen is given by mass over molar mass. So this is mass of nitrogen, that is 28. So the mass is going to be this multiplied by this, so that is 18.1 multiplied by 28, and then we're going to divide by 2 multiplied by 17. This is what that gives us: 18.1 multiplied by 28 divided by 2, which is multiplied by 17. That is going to give us 13.3 grams. So let's try to use copper oxide. We see the mass of nitrogen that we're going to get. So number of moles of copper oxide divided by the coefficient is 3 is going to be equal to number of moles of nitrogen divided by 1. Number of moles is given by mass over molar mass. So the mass of copper given is 90.4 over molar mass. In down already we have got a 3, and then that to multiply by the molar mass of copper oxide, which is 80, and this is going to be equal to mass over molar mass. Now this is for the nitrogen. The molar mass for the nitrogen, 28. So therefore the mass is going to be 90.4 multiplied by 28 and then divided by 3 multiplied by 80. So this one is giving us 10.5 grams. So if we compare, this one has given us 13.3 and this one has given us 10.5. So which one do you think? Which one is the limiting reagent? Is it copper oxide or ammonia? What will be the limiting reagent?
It will be the copper oxide.
Good. So limiting reagent is copper oxide. This means for the next question, just saying calculate how many grams of nitrogen will be produced, then it is 10.5. So this is the goodness of the method. We've already calculated also for the next question. And then now calculate the percentage yield. If 9.3 grams of nitrogen was actually produced, so therefore percentage yield is just going to be equal to actual yield over theoretical multiplied by 100. So the actual yield, we can see that the actual is the one that is given, 9.3. The theoretical is the one calculated, that is 10.5, then multiplied by 100%. So this is giving us 62%. So this is going to be the percentage yield for ammonia. I mean for nitrogen in this case.